push that rock here with some math. Let's solve some simple equations. Okay, so my first example I have here, let's see, can we see that? Yeah. Is x equals 4 over x minus 2. And I'm going to train you though on the first step. There's a lot of ways to handle this, but whenever there's a denominator, especially if there's a variable in the denominator, you want to multiply by whatever the denominator is to make the denominator vanish. So what I'm going to do with this equation is I'm going to take it and I'm going to multiply both sides. So I'm going to multiply the right side and the left side by whatever the denominator is. So I'm going to multiply the right by x and the left by x. Okay. Now this x is going to distribute to both terms here. On the right, you have to if you multiply a side by a value, you must multiply the whole side and do the same to the left, and then you'll have a true equation. What we're doing here is, of course, we know that 1 plus 1 equals 2. But what if I triple both sides? Well, if I triple 2, I get 6. So I need to triple this and get 6. Can we see that? Okay. So I have 1 plus 1 equals 2, and I'm tripling both sides. Well, 2 times 3 is 6. If I just triple one of these ones, I'll have 3 plus 1, that's 4, that's not true. So I have to triple everybody. So that's 3 plus 3, it's still true. So that's the kind of idea we're doing here. We're multiplying both sides by x, but I have to multiply all the terms by x. So over here we get x squared. Over here we get x times 4 over x minus x times 2. Well, here we have some reduction. And so now we have x squared is equal to 4 minus 2x. Now this x squared means we have a equation that's quadratic. And our strategy for solving quadratic equations is to set it equal to 0. So I'm going to add the 2x to both sides. That's going to give me x squared plus 2x, because I can't add those, they're dissimilar, equals 4. And then I'm going to subtract 4 from both sides. Again, this 4 won't add to anything over here, so I have x squared plus 2x minus 4 equals 4 minus 4 is 0. So I have it equal to 0, and now I can use the quadratic formula to solve this. Or I could try factoring. Doesn't look like it's going to factor right off away. Factors of 4 are 1 and 4, which make a difference. And this is a minus, you need a difference. And the difference of 1 and 4 is 3. Or the other factor, not 2. The other factors of 4 are 1 or 2 and 2, but the difference of 2 and 2 is 0, not. So I think it's a quadratic formula time. X equals the negative of what's there, plus the b, plus or minus the b squared, so 2 squared, minus 4 times the a, which is 1, times the c, which is a negative 4, and it's all over 2 times a, which is 1. So we have negative 2 plus or minus the square root of 4. Now this double negative is going to turn into a plus, and 4 times 1 times 4 is 16, all over 2. And we see we're not getting a perfect square, so it was not really factorable in the traditional sense. So we get the square root of 20 here. Now remember, this all over 2 means literally they're all over 2. So this is over 2 and this is over 2. So here I get a negative 1. You cannot divide the 2 and the 20, but you can rewrite the square root of 20 as the square root of 4 times the square root of 5 over 2. And since the square root of 4 is 2, now we can reduce. And so I have x equals negative 1 plus root 5, and x equals negative 1 minus root 5. Those are the two solutions to the equation. And if you need to approximate those, well, you know that the square root of 4 is 2, so the square root of 5 is slightly bigger than 2. So when I add a number slightly bigger than 2 to negative 1, I get a number slightly bigger than 1, so 1.2 maybe. And if I subtract a number slightly bigger than 2, negative 1 minus 2 would be negative 3, so it's a negative 3.2 maybe, okay? About-ish. That's a real rough approximation. Okay, one more example, but this next one's not going to be quadratic, it's going to be linear. And the way you find out if it's linear or quadratic is you do what I said to do in the last one. If you see a denominator, multiply everything by that denominator. So I'm going to multiply this side by 3, but I have to remember that it affects this fraction and that fraction. and then I multiply this side by 3. Well, on the right, we get, can we see both sides of the equation? Yes, we can. So on the right, we get 18x. On the left, when I go 3 times this fraction, the 3's reduce. But I also have to go 3 times that 8. So we have 3x plus 1 plus 24 is equal to 18x. Now there's no squares anywhere, so it's just linear. So we're not setting it equal to 0, we're just solving for x as you learned back in Algebra 1. So at 1 and 24 is 25, and I'm going to subtract the 3x from both sides. So I have 25 is equal to 15x. So that goes away, and I added the 1 and 24 to get 25, and 18 minus 3 is 15. Now I'm going to divide both sides by, look, 5 going this, 5 going that. Let's divide both sides by 5. So we have 5 is equal to 3x. Okay, now I have 3 times x. I'll divide by 3. So I have x equals 5/3. And that is the solution to our linear equation. Math made simple, Simpson math.